Welcome, everyone. Thanks for joining us and thanks for being part of our community. My name is Valen Kolika and I'll be your host for today. A few reminders before we start. If you have issues viewing the stream at any time during the presentation and you're using the web browser version of Teams, please refresh your browser. If you are using the desktop app of Teams, please exit and rejoin. Please note that this webinar is being recorded and will be shared publicly. We will post the recordings on our community at aka.ms/security-webinars. Closed captions in several languages are available during this live broadcast, and you can enable it by simply clicking on the CC button located at the lower right corner of your screen. Now, feel free to ask questions at any time, typing them in the live event Q&A window, simply by clicking on the Ask Question button. Be aware that any questions you post will be publicly visible. If you prefer, you can post your question anonymously, and you can do so by checking the box right below where you enter it. Now, we often get many questions on these webinars, and we will do our best to respond to all of them in real time. In the event if the answer was not provided, or if you may have additional questions post this event, please don't hesitate to raise them on our tech community relevant product spaces. For instance, the one for Azure Sentinel is aka.ms/security/Azure Sentinel community. We love to hear your feedback on how we can improve these webinars, and you can do so at aka.ms/security-webinar feedback. And by the way, all the links that I'm announcing here have been already shared with you on the chat, or that is the live event Q&A window. I would like to also invite you to join our public community by visiting aka.ms/security-community. That's the best way to ensure you don't miss any future webinars or major announcements. On our community, you can speak directly to our engineering teams that create our security products. You'll be able to influence our product designs and get early access to changes by doing things like participating in private previews, which you can sign up for that at aka.ms/prseccom. In there, you can request features, give feedback, review our product roadmaps, register for events, or just simply join webinars like this. We believe that the best way to improve our products is by removing any barriers between you and the people that create them. So we hope you'll join us. In today's session, Innocent Wafula and Booganim will take us over the Better Together session, learning how Azure Sentinel and Azure Defender for IoT partner together to help you detect, investigate, respond to threats using these two environments. Both Innocent and Ahi are program managers, and without further ado, I will turn it over to them. Gentlemen, the floor is yours.
Thank you, Valon, and welcome everyone to our webinar about Azure Defender and Azure Sentinel. So we will start with a quick agenda. First, we shall begin by reviewing the context in which OT and IoT security is gaining importance and the challenges faced by the cyber defenders as they try to address these emerging threat vectors. Secondly, we will learn how Azure Defender and Azure Sentinel partner together to help you detect, investigate, and respond to threats in these two environments. Thirdly, we will demonstrate how Azure Defender for IoT helps detect threats and vulnerabilities. Then we will demonstrate how Azure Sentinel assists us to investigate and respond. And lastly, we will wrap it up with a recap of the session. So why IoT and OT cybersecurity is now a board-level concern? As we all know, we live in a digital transformation world now, where IT and OT devices are no longer air-gapped all the time. Cyber attacks are targeting a lot of OT devices. They are targeting industrial production environments. The impact is huge on revenue, on safety of people and facilities. And also the traditional enterprise SOCs originally were not designed to look into those environments, to the air-gapped environments. And it takes time to get the things moving and start monitoring those environments as well. As you probably know, again, in the last few years, a lot of industrial cyber attacks were introduced. And of course, the first impact and risk is the financial one. We heard that plants in North America, Europe, and Asia were attacked by a WannaCry, and even Honda, Nissan, and Renault were forced to stop the production lines by those attacks. We also know about the North Hydro that caused a loss of almost $70 million by the Locker-Goga malware. Additional big losses to big companies that you can see here on the slide, caused by the NotPetya, Merck, FedEx, and so on. Of course, it's not only the financial risk; it's also the prestige of the brand, and a lot of money has to be invested afterwards for future risks. So our today's CISOs and CIROs has a lot of challenges in this world. First, the IT and OT are starting to converge, and the OT and IoT are no longer an air-gapped environments. They are connected to the internet either permanently or from time to time. There is a lack of visibility by the IT teams or security teams that they are not always familiar with those protocols, with those environments and those devices. And also there is lack of qualified ICS security personnel in the market. So all of this together makes a big challenge for the security teams in the big companies. I want to go a little bit, give you an overview of how we deploy, implement, and use the Azure Defender for IoT. It is divided into several parts, and I will go over it. So first of all, it's very important to mention that Azure Defender for IoT, we call it also the network sensor, is an on-premise device that is monitoring your network in a passive way. It doesn't send anything back to the network, just listening to the network and monitor it. And the top three advantages that you get immediately from installing a network sensor is that you get a very detailed asset inventory about your network. You get a vulnerability management capability, and it provides you a continuous threat monitoring. Now, the first area that the sensor is designed to monitor is the unmanaged devices, the OT unmanaged devices. We also call them brownfield. You can see here a lot of names and brands that are leading the market with those devices. And we are doing it by taking the local network switch and creating a span port or a mirror port and sending it into the sensor. And by that, the sensor is doing DPI, deep packet inspection, to all the traffic that we see coming from the switches, and providing all the information that I've mentioned earlier. The sensor has an on-premise console where you can manage and monitor the sensor locally, and also has a central manager that can be sitting in a central location of the organization and from there you can manage and see all the activity and events and alerts that are coming across your network. Nowadays, we also offer connectivity to Azure, and the central console can run on Azure as well. We're doing it by going through an Azure IoT hub, a very secured way to do it. It's your own personal hub, and everything goes just inside that channel. And by doing that, you will get the option to manage and monitor all your network sensors from Azure, from one location, and get the same capabilities and advantages I've mentioned about asset inventory, vulnerability management, and the threat monitoring. As we are talking today also about the Azure Sentinel, of course, so there is a native connection between Azure Defender and Azure Sentinel. And the Azure Sentinel provides you a converged IT and OT visibility, so you can combine both worlds together into one platform. The Sentinel provides machine learning combined with continuously updated threat intelligence. Every month we are releasing a threat intelligence package that is being pushed to all the sensors in the network from Azure. It is providing investigations and threat hunting tools, and also giving the users specific OT/SOAP playbooks. The other field that we are monitoring is the IoT, the managed devices. Again, we also call it green field. Those devices sometimes has agents, and they are natively connected to the internet and getting the updates and the recent vulnerability packages and stuff like that. Same way, it is going through Azure Defender, Azure IoT Hub, and connects to the Azure. So now I will switch over to our demo. I'll go over the sensor and show you a little bit of the capabilities and look and feel, and go into some of the events that we see there. So this is the main dashboard of the sensor. In the first look, you can see here that who is the user who's logged in, how many events and alerts we have from each severity, and in total. On the right-hand side, you see all the recent alerts that the sensor has detected. We have some counters here about how many unhandled alerts the sensor is currently seeing, and also how much packets per second the sensor is monitoring. This is a demo system, that's why you see the 0, but in real life, the numbers here are in thousands and tens of thousands. So this is, again, the main dashboard, first view that you see when you log into the sensor. Moving to the device map, you will see all the devices that the sensor has discovered in your network. You can zoom in and out and see each and every device, what is it representing. You can get the detailed information about the device itself. You can also switch to a Purdue layout that will show you all the devices where in the Purdue layers they are located. We can also see all the protocols that we identified and how many devices are using this protocol, which subnets we discovered, known application, and so on and so forth. A lot of good information on this banner on the left. As I've mentioned, one of the strengths of the product is the detailed device inventory. So this is how it looks, a very detailed table that can be exported into an Excel file or CSV or PDF. You can also change the columns, choose what you want to see and what you don't want to see. You can change the order and so on and so forth. It gives you again the IP, the name, when was this device was last seen active, what type of device it's, vendor, MAC address, and so on and so forth. I want to focus on the alerts tab here and try to walk you through an event or a chain of event that will later on will be also shown how is it reflected with the Sentinel part. So I want to focus on an event that is called an S7 stop PLC command, or in general PLC stop command. Of course, a PLC stop command shouldn't be given just like out of the blue. It has to be a known command and come from a known source. And if we see it, we alert about it, and we expect that the user or the analyst will investigate a little bit around it, especially if it came from an unknown device or an unknown in an unknown or an non-maintenance window. So what we think led to this event to happen? So first of all, we see here there was an unauthorized internet connectivity. This is the first red flag that we should think about. Who is this source and destination addresses? Why this connection was allowed? If it's legal, if it's not legal, and using that, I will also explain. If you acknowledge it, it means this event or this detection is legal, and we can acknowledge it and confirm it. But in the future, we want to keep getting those alerts. If you learn it, it means it's okay, it's legit, and you don't want to be alerted about it anymore in the future. So first step, we found out that there was an unauthorized internet connectivity. That's the first red flag, as I said. Then we see that there was a port scanning detected. So maybe the intruder from the internet was trying to crawl into our network and start to scan which port are in use and open and available, and maybe there can be a door for the network. So that's the second alert that should draw our attention. The third one will be that we will find the excessive SMB login attempt. So somebody came into our network, found an open port, and now is trying to log in by running some scripts or algorithms and trying to log into the open machines. And eventually, as we said in the beginning of the event, we got a suspicious stop command, PLC command. Again, not during maintenance window, not from an authorized user, maybe not from an authorized device, an HMI or workstation. So this is something we definitely want to block, want to avoid, and want to take care of. If we also want to investigate it on the timeline, it gives us a visibility into how this happened along the time, and how this, what happened before, during, and after the event. If the analyst is doing their investigation, they can add some remarks along the timeline, so the next analyst will keep the investigation, so they can see the remarks that the previous analyst left. Want to transfer the stage to my colleague here, Innocent, that will take it from here and will show you how those things are being seen from the other side, from the Sentinel side. So Innocent, go ahead.
Yeah, thanks, Ahi. Let me get rigged up here in a moment. All right. So thank you very much of setting that stage as we go further into the topic, looking at how Azure Sentinel builds on top of the capabilities of Azure Defender for IoT to make it that much easier for us to investigate and respond to attacks leveled at your OT and IoT environments. All right, so now, one of the reasons that Azure Defender for IoT and Azure Sentinel partner so effectively together to broaden visibility of the threat landscape for SOC and OT teams is by leveraging Microsoft's extended detection and response solution that taps into signals across vectors such as data, devices, endpoints, identities, and network, giving Azure Sentinel that unique vantage point to generate enriched and actionable insights for the benefit of SOC teams. Moving along, let us now look at two dimensions that bring alive this combined value proposition that deep integration between Azure Defender for IoT and Azure Sentinel provides. And these are native functionality and OT-specific benefits. Native functionality. Azure Defender for IoT and Azure Sentinel deliver converged IT/OT threat landscape visibility across both environments, addressing a coverage gap that has been a challenge in the industry for quite a while, as Ehi mentioned earlier on. Machine learning paired with continuously updated threat intelligence helps to augment the capabilities of your SOC analysts. With the elasticity and scalability of Azure as a cloud platform means that you never have to worry about capacity as your security requirements will continue to evolve, and reduced complexity and total cost of ownership means that we empower you to focus on security and not on deploying and managing servers. OT-specific benefits. So the deep integration between Azure Defender for IoT and Azure Sentinel means that you get rich contextual information about specialized OT devices and behaviors detected by Azure Defender for IoT. We enable your security operations teams to accelerate investigations and threat hunting, while with deep integration between Azure Defender for IoT and Azure Sentinel, we make it possible to correlate and detect modern kill chains that move laterally across IT/OT boundaries and vice versa. IoT-specific threat intelligence. So in addition to the trillions of signals we are already collecting daily as Microsoft, Azure Sentinel now taps into the IoT/OT-specific threat intelligence provided by Section 52, which is our specialized security research team focused on IoT/OT vulnerabilities, malware, campaigns, and adversaries. IoT/OT-specific SOC playbooks. These enable automated actions to swiftly remediate IoT/OT threats, and we'll be looking at a little bit of this in an upcoming demo. Okay, so let us now pick up from the demo that my co-presenter Ehi did earlier on and build upon the detections that Azure Defender for IoT supplies to Azure Sentinel for further enrichment and context addition. So first off, of course, we want to connect Azure Defender for IoT to Azure Sentinel. And being two natively integrated solutions from Microsoft, you can expect that that process is smooth, straightforward, and pretty quick. Indeed, with just one or two clicks, you will be able to connect Azure Defender for IoT to Azure Sentinel. And once you do that, you'll be able to start taking full advantage of the combined value proposition. So as next steps, first thing you really want to do is to enable the Microsoft incident creation rule for Azure Defender for IoT. And what this will do is take those Defender alerts that are coming into Sentinel and automatically convert those into incidents. We also have provided you with some sample queries there that you can use to make a quick check against your workspace to see whether indeed you've got the data there. And once you have that data there, you can start to do your investigation and response activities going forward. We also have a built-in workbook that gives you visibility into the alerts coming out of IoT devices around your environment, so you can use that as a companion tool as you do your investigative activities. Okay, so with the connection to Azure Defender for IoT already made and the Microsoft incident creation rule for Azure Defender for IoT enabled, we can now expect to see incidents generate. Sorry, I've got an alert in my house. 1 second.
It happens. This is all about being live. Good to go.
Okay.
Listen.
Yeah, sorry. 1 second. I'll just proceed because we really don't have an alert. It's a false positive. I hope it's not interrupting the background. So anyway,
no, it's not.
Okay, good. That's actually what Teams does. So as we saw from the Defender side, unauthorized internet connectivity is one sample alert that can come from that side, and using that rule, it's automatically piped into Sentinel where the incident is created. What you'll also notice is that from that deep integration, the incident name and the alert name are identical as they move across from Defender to Sentinel. Same thing applies to the excessive SMB login attempts and the S7 PLC command as well. Now, now that we have the data already in Azure Sentinel, let us now look at how we can take advantage of some of the built-in features within Azure Sentinel that enhance the combined value proposition of the two products. So the first one was the unauthorized internet connectivity detected. So potentially what you could benefit from on the Sentinel side is take advantage of the threat intelligence within Azure Sentinel and investigate the reputation of the public IP that was involved in this alert and inform your further actions going forward. You could also use a watch list to determine or to refine the kind of activities you want to do in response to this alert being detected. So maybe for specific types of devices, you want to take a certain action. So pairing that up with automation, you can be able to respond appropriately. Taking advantage of the user entity and behavior analytics, this could also log an anomaly within one of the tables in user entity and behavior analytics, and this could now be used subsequently to perform correlations and build additional or custom threat detection solutions. So for the port scan, again, if we have a situation whereby you conduct some port scans for whatever reason, it could be penetration testing, you could also take advantage of the built-in watch list to dismiss these alerts so that whenever that activity is happening and is known to be legitimate, you can save your SOC of their precious time. For the excessive SMB login, you could also take advantage of automation within Azure Sentinel and be able to take actions such as blocking the user, blocking traffic to that targeted host in order to limit the potential damage that could happen if that progressed. For the final one, the S7 PLC stop command, this is a serious one, as Ahi mentioned. So you could potentially want to block the traffic to that host, isolate the machine as well, so that you can limit the damage and begin to investigate and get on top of things. So by no means, this is not a full exhaustive list of the capabilities within Azure Sentinel that you can take advantage of, but just to show you that tight integration and added value that Sentinel brings when you connect Azure Defender for IoT to Azure Sentinel. Okay, so we have seen how incidents are generated using the built-in rule. Let us now look at how we can use a custom rule to address a specific scenario. In our demo, we want to detect a PLC stop command issued outside predetermined maintenance windows. A PLC stop command, of course, is highly sensitive, as Ehi had mentioned, and is one that you do not expect to occur casually. So ideally, it should only happen during rare maintenance periods. So to detect for this scenario, we will turn to the power of Azure Sentinel to correlate multiple alerts across Microsoft Defender for Endpoint, Azure Defender for IoT, lookup lists, and orchestrate across multiple domains, including an on-premise firewall, to mitigate this threat. We'll also take advantage of the investigation graph built in within Sentinel to perform our initial investigation, and then also use the Defender for IoT alerts workbook to take a look at how alerts have been trending in our environment lately. Right, we'll switch over to the demo now. So here we have our Azure Sentinel portal. I will go straight to the analytics blade, and I already have the custom rule created. I'll just pull it up and then walk you through it. So here we have it. PLC stop command issued outside maintenance window. Okay, so we will open this up and then go straight to the rule logic, expand this out a little bit, try to make it bigger here. Okay. All right, so the first thing we are doing here at the top is we are defining the maintenance window. So we want to know in future, if this famous PLC stop command happens, then the first thing we want to check, is it happening during predetermined maintenance window? So SEM 1, SEM 2, this really referred to semester 1, semester 2. You can put whatever you want if you grab hold of this query and make your own changes. Second thing we want to do is actually to look at our environment and search for any malicious credential theft tool activity having been recently executed. So this is important because if you remember the Triton incident, one of the first things that happened was credentials were stolen, and this type of activity was affected. So we are now taking advantage of that XDR capability that Microsoft provides to take advantage of Defender for Endpoint, make that quick check and see, did this type of suspicious and potentially serious activity happen within a time we consider close enough? So obviously we're looking back 5 hours. It could be shorter, it could be longer. We are then going on to extract the host name where this activity was performed, the malicious credential theft tool being executed. And then we're also extracting the last external IP address that this host here communicated with, because that is of importance to us. We then go on to dig deeper into the S7 stop PLC command. And what we are doing here is we want to extract the device, the source address, meaning the device that issued the stop command. And we also want to see where was it directed to. And then further down here, we are taking advantage of a built-in function within KQL to look at whether this stop command came from a subnet that is authorized. So of course, if it is false here, meaning not belonging to this subnet, that's already a problem. And we are gaining confidence that this is indeed something serious and worth a much closer look. Then we are going another step ahead to say, so if that device that issued the stop command, is it an authorized device? So here we are being very explicit and saying in our environment, we have determined that only this particular device is expected to issue a PLC stop command. So if this command comes from any host that is not this one, then again, we are ratcheting up our confidence to say, indeed, we have a problem here. The damages here are just to create common columns that we can use to correlate all these various data sources that don't necessarily have a common column in their original schema. And now here we are doing the actual lookup against our maintenance window and checking did this activity happen on something that is not between our expected maintenance periods? And then we are projecting that so we can use it later on. So as we go further down here, we take advantage of the GUI-based entity mapping experience in Sentinel to perform the entity mappings, because when we go to the investigation graph, we will need to have performed these mappings. So this can appear in the investigation graph and give us a good visual as to what's happening. And also it is necessary to be able to extract them and use them for the orchestration that you would do with the logic apps further along. And something else we are doing also is taking advantage of the custom details capability within Sentinel. And what we want to do here is to surface the name of the maintenance window dynamically as the alert is generated and as the incident is generated. So that's done for now. Of course, the look back periods are kind of a bit off because we just wanted to make sure for demo purposes we have the data that we need. But obviously welcome to adjust yours to whatever is functional for your environment. All right, so with the rule created, we go back to our Sentinel portal. We go to the incident blade and check whether we have had a PLC stop command incident, and indeed we have. And then I go on to check the full details here, select the timeline. So as you can see here over on the left, I get a bit of details and the evidence, the number of events that generated this alert, the alerts, the entities involved, and here I see the timeline. And what you'll notice here is that dynamically, this alert has had the maintenance window appended to it. So this is coming from the custom details, which is definitely a value add coming from Azure Sentinel. And then if you look further down here, you see there also the custom detail has also been surfaced down here. And of course, we've got our entities there. So now we want to investigate further. We hit the investigate button, takes us straight to the graph, the investigation graph. As you can see here, we have this very nicely laid out graph showing the relationship between all the entities that were involved. So for example, if I wanted to see details about this particular entity, I get quite a bit of detail around it. I see the name, the OS, the last external IP, and all these details. As you can see here, I also have the IPs for the PLC devices and the ones that issued the stop command, as well as the public IP as well. So now I can go back to Azure Sentinel over here and go over to the workbooks, look for my IoT alerts workbook, pull it up over here. As part of a companion investigation tool, I can start to see what sort of alerts have been trending within my environment lately. And as you can see over here, I have quite a number of them. And this kind of just helps me to build more and more context as I perform my investigations. So that is the custom rule and the workbook and the investigation graph that we can use for our initial investigation. Let us now look at how we can bring this all together within an automation rule that helps us to perform that automated response that is definitely very important because it helps us to accelerate and take action whenever something goes wrong. So to do that, I come down here to the automation blade within Azure Sentinel. I already created my automation rule over here. I gave it a name over there. And then what I do now is that I start to specify the conditions. So in this case, I say that I'm looking to pair this automation rule to this very specific custom alert or alert rule that we created called the PLC stop command issued outside maintenance window, because we want all these logic apps and orchestrations to only apply to this specific rule. So just to see the level of flexibility that you get over here with Azure Sentinel automation rules. Then we start to select, pick and choose the kind of responses that we want. So we have this logic app, whose job is actually to block an IP within the firewall level. The way this works, and by the way, it's in GitHub, so you are free to go over there and download it and use it in your environment as well. And the way it works is that it will send an adaptive card through Microsoft Teams to the SOC team of your organization. And then if they go ahead and agree that this particular IP should be blocked, then automatically actions will be orchestrated, go into the firewall and perform that blocking. So that's an example of how we can actually take an entity from Azure Sentinel. In this case, it would be that public IP that we surfaced from the Defender for endpoint, and then use that to go and block it in a third-party tool. Second one we would want to do is using the Microsoft Graph Security API, and then send an indicator into the threat intelligence that would have the overall or ultimate effect of blocking that IP from being accessed by any device. So if you think about the purpose of the first logic app, it would potentially function within a physical boundary. So either the factory, the plant where the PLC is, and obviously there are other devices in there that could be under attack. So we want to perform that block at a physical level. Then now with Defender for endpoints, we actually have this capability being a cloud service. Once that indicator is sent through to the Microsoft Security Graph and marked as an IP to be blocked, it will apply to all the devices that are enrolled to our tenant, and that means these devices could very well be outside the boundary of the network, which of course is a great thing. The other thing we might want.
Sorry to interrupt.
Some folks not being able to practice.
I'm sorry.
Do you mind zooming in this? Okay.
Sorry about that. Okay, so, all right. Is that better? Okay.
Thank you.
Okay, so I guess since it was a visual issue, you can see the logic apps up here, the Palo Alto one, and then the Graph Security API based one, which applies to Microsoft Defender for endpoint. And now another thing you could do. So by the way, these again, as I said, are logic apps that are already in our GitHub, so you can take advantage of them. So again, here selecting one additional one that would perform the action of extracting CVEs from the IoT devices, so that we add that to comments in our Azure Sentinel incident, and that helps us even as we investigate, and also as follow-up actions to go back and say, okay, maybe this happened because there's a vulnerability here. Let us now go and do our patching and stuff like that. Again, this list could go on and on. So what I'm doing here again is to say this is a big deal. So a PLC stop command is a big deal. So we don't just want to rely on either a Teams message and an analyst seeing it. We want to really take proactive and aggressive action. So we can actually also use logic apps that are capable of sending SMS alerts. So again, as part of the orchestration in response to this particular incident, we can have a logic app that actually sends an SMS to somebody that needs to take immediate action and get engaged in addressing this issue. So that's a run through of how you would be able actually to not just investigate or detect the alerts that are coming in from Defender for endpoint, create incidents around them, or build custom rules that are very specific to your requirements, and then go ahead to say, I want to go another step and automate my responses to this action so that they happen quickly. Okay. With that, we will proceed on to our close. And in closing, we will do a quick recap here. And basically, this is a summary of the benefits that you can expect from Azure Defender for IoT and Azure Sentinel working together. Number one, you get visibility into the devices you have and how they are communicating, so you can easily implement better segmentation and zero trust policies. Number 2, identification of risks to your crown jewel IoT assets and how to prioritize the mitigation, so you can take quick and proactive action. You also get continuous visibility into threats targeting your IoT OT environments and improved operational efficiency from that deep integration and automation across the two solutions. Lastly, and very important, is that ability to bridge the visibility gap into OT environments, leveraging Microsoft's extended detection and response solution. Valon, back to you.
Thank you so much. I was just responding here in one of the questions. Let me just check here if we have any. I believe the team here did a phenomenal job by answering all the questions, but please let me know if there's anything outstanding there, or if you have like additional comments to comment anything major that was mentioned during the webinar. And while you're thinking of that, I'll go ahead and do a quick wrap up here. So just wanted to, well, first of all, thank you, Innocent and Ahi, for being our guest today and for an excellent presentation. And also thanks to the team for helping us answering all these product-related questions. I would like to remind the listeners that the best way to ensure that they don't miss future webinars or major announcements to visit us on our landing page at aka.ms/security-community. And while you guys are there, you'll find easy ways to navigate and find resources, learning content that is relevant to our security products, perhaps the products that we just shared here with you today. And good start would be simply by browsing the bite-sized product videos that we have, ninja trainings, recording of the past webinar. There was actually a good question earlier where one of the folks was asking how they can access the live event Q&A, because that's normally it's not part of the recording that we provide. What you can do is to access the live event Q&A for later, use the same link that you used to join this webinar. That's basically the link that provides you also with a recording, as well as you'll find the Q&A questions and answers. So please take a minute by submitting your webinar feedback at aka.ms security webinar feedback. Now, in case you have additional questions that we missed, you can always visit our tech community site. And for today, we talked about Sentinel and Azure Defender for IoT. So the relevant spaces for that would be aka.ms/Azure Sentinel community, and for Azure Defender for IoT, aka.ms/AZDEF for IoT community. Okay, well then, let me just take another look here. No more incoming questions. Thank you so much. And I would want to thank all of you for being part of our community and for joining us on these webinars. So we hope to see you next time. Goodbye.